little dude. Okay. Alright. So now I'm going to try to do a few of these both ways. See how it looks. Square root of 50. I could break it up as 5 times 10. And that would sort of be doing method 2 here, right?
Yeah.
So I could do, okay, 50 is 5 times 10. 10 is
5 times 2.
5 times 2. And then it becomes, I'm looking for groups of 2. So I see 2 5s. So that means, what can I put down here? 5
Square root of 2.
square root of 2. But again, this is not a bad way. This is a beautiful way to do this. But there's so many little places people make mistakes. They don't carry everything down, and then they put things in the wrong place. This other way, to me, it just is more obvious why things go where they do. So if I do it the other way, the biggest square number that goes into 50 is 25. So I get square root of 25 from square root of 2. Square root of 25 is 5. Square root of 2 is, I don't know. So thank God we get the same answer either way. I like it. Number 2, I like that. Let me do it method 1 first. Let's see. Actually, screw it. Let me do it. It doesn't matter yet. But do it this way.
9 times 8.
Yeah, good. 9 times 8. 3 times 3. 2 times 2 times 2. And here's where people get a little confused because what are there 2 of?
2 2s and 2 3s.
Good. Everything is doing what to each other? Multiplying. So you can take a 3 out and a 2 out, and they're multiplying. And what's left inside?
2.
That last little poor 2 dude that had nobody to go with. So what's the answer?
6 remainder square root of
6 rad 2. I like it. Now what does it look like the other way? Let me purposefully do the wrong sort of first step. So if I do 9 times 8, it's not wrong, it's sort of like reducing, what, Jeff? I don't know, Jeff. It's like reducing a 12 24ths to become 6 12ths. Is that wrong? Not so far, it's just not done. So here, square root of 9 is 3. Square root of 8, I don't know, but 8 is 4 times 2. So it's just like reducing a fraction and not reducing enough on the first step. So what could I have taken out as 72? I could have written 72 as 36 times 2. And then I would have gotten 6 rad 2. But I'm going to get there eventually. What's rad 4?
2.
Times 3?
6.
So I do get 6 rad 2. Just took me a little while. Okay, how are we doing? Did I do that the other way? Yes. Okay. Alright, so 120, if I do it break it all the way down to its DNA, I could do 10 times 12, 2 times 5, 3 times 2 times 2, and I'm looking for groups of 2. So I see 2 2s, and everything else is a single, so that's too bad for them. What's left inside then? 30. So if I do it the other way, the biggest square number that goes in is 4. 4 times 30. Square root of 4 is 2. Square root of 30, I don't know, so I get the same answer either way, thank God. Okay, hopefully one of these ways makes sense. There's no real third way. So it's some combination of these things. Alright, let me see. So before I could do 8 times 10. 2, 2, 2, 2, 5. And again, I see 2 2s and 2 2s. So 2 times 2, 4, and I have a rad 5. I like it. The other way, 16 times 5 is 80. The square root of 16 is 4. Square root of 5, I don't know. 4 rad 5, same thing. Now obviously, just like if I said reduce 3/7, you're allowed to stare at me a little bit. So I'm done. So reduce rad 33, we'll circle it, or say not, can't do anything, or already simplified, or something. Give me some indication you understand that ain't going to. It's 3 times 11. What's there 2 of? Nothing. Does that mean you can't do the square root of 33? Of course you can. It's just not going to be any pretty. It's like 5 point something, right? Okay. This one we should all know.
4.
There's no real work to do. Yeah.
4.
So look for those. Look for the nice ones. What can you do with number 7? Now we're moved on to cube roots, but they work the same way.
8 times 5?
Alright, I like it. 8 times 5. Cube root of 8 is...
2.
Cube root of 5 is... I don't know. Just don't forget the little 3 dude. It's still a cube root. It can't morph into a square root. So what about number 8? I like it. So it sounds like, at least the more vocal of you, do it that way. How many of you guys broke this down like 9 times 6, and then 3 times 3 times 3 times 2? Right? How many of you guys do it that way? Anybody? A few of you guys? Okay. Just the quieter ones, I get you. So what am I looking for here? Groups of 3. So at front I can put 3, and inside is that poor little 2. What? Now the other way, like you said, I can make this cube root of 27 times cube root of 2. Cube root of 27 is 3. I get the same answer either way. So just pick a way that makes more sense. I am pushing you a little tiny bit to do it this way. But if you don't do it that way, I'm not going to hate you or something. Oh yeah, -1 just cuts. No, I'm not going to do that. I don't think so. Let's see how I feel. No, I'm joking. You can do it. Either way is fine. They're both legal. But this is an example of one. I mean, what definitely goes into 888? Hey. The cube root of 8 is 2. Now, 111, you can divide that by something. 1 plus 1 plus 1 is... So I can divide 111 by 3. 3 goes into 111. Anybody try it? 37 times. And 37 is prime, so it's not going to go anywhere. So I'm done. Now be really careful. That only works with 3 and 9. If you add all the digits together and it's a multiple of 3, 3 goes into it. If it's a multiple of 9, 9 goes into it. Don't think that works for everything. It's only those. Finally, number 10 is very quick. That's the answer. I need cube root of 1,000 I can do. Why would that work? Because 1,000 is 10 times 10 times 10. So that would be 10. So this has 1 too few tens. It's only 10 times 10. It's not 3 of anything. That's why it's done there. I like it.
Yeah, do 24 times 25 times 4. Take the 5 out.
It's a cube root, not a square root.
Okay, yeah.
If it was a square root, it would totally work. Yeah. All right. One last thing, and then I'll let you guys go. And this will take less than 2 minutes. What does your gut tell you? Well, first off, what is 4x plus 3x? I know, it tells you you're hungry. 7x. It's crazy, right? Does it matter what x is?
No.
That's always true, no matter what x is. Do you understand that?
Yeah.
So what do you think this is? Did you ask coefficients? Yeah, 4 square root of 2's plus 3 square root of 2's is 7 square root of 2's. Yes, no?
Yeah.
Alright. Because these are like terms, right? So what about this? That is so desperately not square root of 10. I don't see any square root of 10s. How did you make them? You can't do that. Are these like terms? But can you make them like terms? Yes. Because what's this? So it's 2 rad 2 plus rad 2 is 3 rad 2. 2 of these plus 1 more is 3 of these. So that's the immediate, not the only thing, but the immediate usefulness of what we just did is to make things radicals like terms. That's one little thing you can do with it. See, that was even less than a minute maybe. So that's enough for today, I think. We've done 3 sections out of chapter 10, not 12. Okay. We'll probably have a quiz on Wednesday. We'll talk about it tomorrow.